Good afternoon, my fabulous chemistry students. Lecture number 3, half reactions. I'm sorry last one went long. This one might go even a smidgen bit longer before we get to the real short ones. So today we need to be able to identify what element has gained or lost electrons. By doing that, what we're going to do is split these reactions into half and look at them half at a time. Okay? We need to remember oil rig, or Leo says GER. Oxidation is losing oil. See right there, oil. Oxidation is losing. Reduction is gaining. See what I'm saying? Oil rig, man. Oil rig is how I do it. A reaction is redox if and only if the oxidation numbers change for two elements within a reaction, not just one. Okay, we need both, and that was kind of what I was getting at in the first two videos without actually saying it. The reduction GER, or the rig, right, or the rig, gain of electrons by an atom or an ion, the oxidation numbers go down or reduces. Okay, oxidation, or Leo, and in this case it's oil. Loss of electrons by an atom or oxidation or ion, the oxidation number goes up. So now we need to do this real quick, assign oxidation number and figure out what's going on. So I'm going to do it on the actual example, and then we'll fill in the chart together, okay? So carbon, it's by itself, it has to be a 0. I'm going to do that. I'm going to do it again over here. H is by itself, so it has to be a 0. Let's get that out of the way right off the bat. Then we got this. O is a -2, so oxygen has to be a +1. 2 plus 1s equals 2. 2 and a -2 equals 0. Okay, good. On this side, I've already actually, let me slow down and just say, hey, listen, when I have these lone elements that are 0, they're always the ones that are being oxidized or reduced because they're not 0 on the other side. Okay. Now, oxygen is a -2, so carbon must be a +2 because there's one of each. So now, carbon. Charge increases or decreases. I'm going from 0 to a +2. My charge is increasing because I am losing electrons. If I lose a negative, I become more positive. So now we have to deal with that backwardsness. But we've done this before when we did bonding. So if an electron is lost, oil rig loss. Here in the oil or the Leo, the loss is oxidation. And I'm telling you guys, this is the part where I really need it written on the top of my page to say oil rig or Leo GER. Leo says GER. You got to, I can't do it without that written there. Right now I have it written on the notes right in front of me, so I'm good. Okay, I start from H + 1 and I go to H0. The number is getting smaller. Okay, so it is decreasing. Sorry, I should have wrote increasing here. Not circle it because I couldn't tell you what the circle went for, which one. If I am decreasing, I must have been gaining electrons. And gaining electrons is GER, or the G in the rig. So this is reduction. And again, reduction, I am decreasing or reducing my charge. So we have one more example. And because this stuff is kind of complicated, I am going to go through this with you guys, okay? Specifically, when I see that there's two compounds on the left-hand side, I think, oh my God, this could be a double replacement reaction. This could be a double replacement reaction. But here, right off the bat, I see a lone element, so here's where things are going to get a little bit complicated. Let's start with that. It's 0. MnO2. O2, whenever I see an O2, the oxygen is always -1. That gives me a total of -2. Mn must be a +2. Let me just verify. Yes, Mn can be a +2. HCl. Cl is a -1. H is a +1. MnCl2Cl is always a -1, which gives me a total charge of -2. So Mn must be a +2. So I have an Mn as a +2. Oh, see, they did something wrong. Magnesium oxide is a -2. That's how I get a +4. Mr. Mooks, is that true? Magnesium oxide is not a peroxide. Oh, peroxide has to have an H2O2. Okay, so I jumped the gun. When I saw the O2 at the end, I jumped. The peroxide has to be H2O2. It's specifically peroxide. All right, so O2 is a -2. It gives me a -4 charge, so that's a +4 charge. See how easy it is to make mistakes on this stuff? Cl is a -1 always, so I have two of them. This is a +2, so here's a change in charge. Cl here is a 0. H2O, I got a -2. 1 -2, I need 2 +1s. No change there. The other ion that's changing is Cl and Cl2. It goes from a -1 to a 0. So here we go. I have a -1 goes to 0. That is increasing. Increasing in charge means I must be losing electrons. Losing electrons is oil in the rig, so it's oxidation. Because oxidation is losing. Mn goes from a +4 to a +2. It is decreasing. Decreasing must mean a gain in electrons. A gain in electrons is oil rig. Rig is reduction. There we go. Now, Mr. Milks, I'm taking a lot of time doing this, so it's time to hurry up. Oxidizing agent, reducing agent, this gets a little bit complicated. I'm going to go through it real fast. Basically, the oxidizing agent is the species that is reduced, or the species that does the oxidizing. The reducing agent is, again, the opposite. It's the species that is oxidized, or the species that does the reducing. The reducing agent is what does the reducing, so it's backwards. Okay, I'm going to kind of skip over this because this isn't really on the test ever. They're always on the reactant side of the equation, okay? Half reaction. Now, this is the meat and potatoes of what we need to get onto. Half reactions allow us to show the exchange of electrons for each redox. For each reduction reaction, we can illustrate two half reactions. One half reaction is, of course, the oxidation. The other one will be the reduction. Okay? So I have this one thing going on. This is what we call a half reaction, and it's a reduction because I am gaining electrons. Notice the electrons are on the reactant side. Electrons on the left-hand side are gained, and in this reaction, GER or rig, whichever one you prefer, is reduction. So that's where I get my R. Rig and GER have the R in it. Okay. Let me write the rig again because I like oil rig better. Charge goes down because Fe gains electrons. Reduction is gained. An example of an oxidation half reaction is the Fe going to Fe3 plus 3 electrons. Now I lose them because they are on the product side. Okay, now we are talking about Leo or oil. So that must be oxidation. Again, oil or Leo, because I am losing. Okay? This is where you press pause and I keep going. Here we go. Notice always add electrons to the side of the reaction that has the higher total charge. Remember, electrons are negative. Following the law of conservation, half reactions follow the law of conservation of mass, and they have the same number of atoms, but now we add on a wrinkle. It's going to also follow the conservation of charge. The net charge must be the same on both sides. So this is where we get to add a little bit into how we balance equations. Now, here's a whole set of rules that we need to know, and we're going to use. I'm going to talk my way through them as I use them on the next page. I'm not going to take the time to read them for you because that's going to make for an extremely long video. Okay, so oxidation numbers to all elements or polyatomic ions, label the brackets for reduction, RED, and oxidation ox, or RNO is fine with me. So let's start in with the numbers right off the bat. Mg is by itself, it's got to be 0. Zn is by itself, it's got to be 0. So notice I do that. I try not to get confused there. Cl is always a -1. I have 2 of them, so Zn has to be a +2. Cl is a -1. Notice the charge in Cl is not changing. It's a +2, so or a -2, so Mg has to be a +2. So magnesium is going from +2 to -2. Is it gaining electrons or losing? It must be losing, so that's oxidation. Oil rig. Oxidation is losing. Okay? Zn goes from +2 to 0. It's going down in charge or reducing. You can know that reducing is like down in charge or RED. Okay? Okay, oxidation half reaction. And reduction half reactions. Oh, I was supposed to write them out. So sorry. The Mg is going from Mg0 to Mg +2. And it is oxidation, so it is losing 2 electrons. Zn plus 2 electrons goes to Zn0. Now notice the number of electrons is the same. Well, that's good for now, but there's going to be cases where they're not, and we're going to have to balance the equation based on it, of course. Okay? We are going to skip number 2. Because Mr. Milks doesn't like it. There's an HG. Oops, sorry. I'll explain why real quick. There's an HG with a 0 and an HG with a 0. There's a typo in this, and we're not going to even deal with fixing it. Okay, but we need to be able to balance charges. So let's go through and do this one all the way through, and we'll see how we have to balance the electrons. Let's start with copper is a 0, and silver's got to be a 0. And nitrate is a -1, so silver must be a +1. If nitrate is a -1 and I have 2 of them, copper here must be a +2. So I have copper. Oh, who's oil and rig? Who's losing and who's gaining? If I go from 0 to +2, I am losing, and oil. Oxidation is losing. So here's my ox. Silver, +1 going to 0, that's a reduction in number, so it's reducing. I can't spell. R-E-D. Okay, not so much coffee before we make notes, Mr. Milks. Okay, we tend to get rambly. Let's do this now. Cu with a 0, sorry. Cu, just regular Cu, plus some number of electrons is going to get me to Cu +2. The oxidation number is where I see that. That's going to be a +2 electrons. And the plus is, of course, already written there for me, so it's just 2 electrons. And then the other half, I have Ag with a +1, goes to Ag with a 0. The difference in the oxidation numbers is 1 electron. So Ag plus 1 electron goes to Ag0. Now we need to balance our electrons. Okay, I need to multiply this whole thing by 2 so that the electrons goes to 2. Okay, so if I take this whole thing and multiply it by 2, I'll get 2 Ags plus 2 electrons equals 2 AgOs. And now the 2 electrons and the 2 electrons balance, and we have obeyed the conservation of charge. So there we are done. I tried to get through it as fast as I could, but there's a lot to it. So we really got to take our time with it at the same time. And I need you to be able to take your notes adequately. So we can now identify what element is gaining or losing electrons. Please don't forget, we need to use this religiously. Either oil rig or Leo says GER. Your choice. I don't really mind which one you use. I just am very much schooled with oil rig. Follow the rules and identify the oxidation numbers of the half reactions. And now we get to practice. So after homework 2, I'm sorry, after homework 3 we just did, I can start on page 12 of my practice packet, and I can get through now page 16, and it's not 4 pages. There's a page or 2 in there deleted, and we are all set for this. Good luck, and I will see you in class tomorrow. Next one's really short, guys, I promise.